Alright, so Meta just proved you can teach a robot to understand physics, predict the future, and control robotic arms in completely new environments with just 62 hours of robot footage. This isn't science fiction, this is V-JEPA 2, and it's about to change everything. That's like watching YouTube non-stop for 114 years. But it didn't just memorize what it saw, it learned the fundamental rules of how our physical world actually works. Let me explain what makes this revolutionary. Most AI models predict the future by generating actual pixels, trying to recreate every tiny detail. Imagine predicting exactly how every leaf moves in the wind or how water ripples form. It's computationally insane and mostly pointless. V-JEPA 2 does something far more intelligent. Instead of predicting pixels, it predicts in representation space, learning the underlying concepts, the physics, the relationships between objects, not meaningless visual noise. This is based on JEPA, Joint Embedding Predictive Architecture, pioneered by Yann LeCun, Meta's chief AI scientist. The philosophy is simple but profound. Humans don't learn by memorizing every pixel we see. We learn concepts, relationships, and physical laws. A baby doesn't need to see a ball drop 10,000 times to understand gravity. They get it after a few observations because they're learning the principle, not the pixels. V-JEPA 2 has two components. An encoder that takes raw video and converts it into meaningful representations, understanding what's happening. A predictor that imagines what happens next. During training, they mask portions of video and challenge the model to fill in the gaps with meaning. The training happens in two brilliant stages. Stage 1 is completely self-supervised, no human labels, just raw internet video. Over 1 million hours of diverse footage. From cooking videos to sports to object interactions. The model learned how objects move, how people manipulate things, how physics works, all without anyone telling it what anything was. Stage 2 is where it gets impressive. They added just 62 hours of robot control data from the Droid dataset. Just 62 hours. In this stage, they fine-tuned the predictor to understand how the world responds to specific robot actions. This action-conditioned training transforms V-JEPA 2 into a tool for actual robotic control. The performance numbers are staggering. On something V2, which tests motion understanding, V-JEPA 2 hit 77.3% accuracy, state-of-the-art performance. On Epic Kitchen's action anticipation, predicting what actions someone will perform 1 second into the future, it achieved 39.7% recall, better than any previous model. When combined with a large language model, it scored 84% on perception test and 76.9% on temp compass, both cutting-edge video question-answering benchmarks. But robotics applications truly showcase this world model's power. Meta deployed V-JEPA 2 on Franca robot arms in their labs, and these robots had never seen these environments before. For simple tasks like reaching or picking up objects, they give the robot a goal image. The robot uses V-JEPA 2 to imagine hundreds of possible action sequences, predicts which ones will get closest to the goal, and executes the best option. For complex pick-and-place tasks, they provide visual sub-goals, a sequence of images showing the steps. The results? 65% to 80% success on pick and place with completely new objects in completely new environments. No task-specific training. No environment calibration, just the world model working. They trained on robot data from completely different robots in different environments, then deployed on their lab robots without additional training. The model generalized across different camera angles, lighting, objects, everything. That's the holy grail of robotics, true generalization. Meta also released 3 benchmarks. IntPhys 2 tests if models can distinguish physically plausible from impossible scenarios. Humans score near perfect. Current AI models are barely better than random guessing. Minimal video pairs create similar-looking videos requiring opposite answers to the same question. CausalVQA focuses on cause and effect reasoning. These benchmarks reveal that while models describe what happened well, they struggle reasoning about what could happen or why. The implications are staggering. This proves Yann LeCun's vision that AI can learn about the world through observation, like humans, then use that understanding to plan and act in new situations. Think about the applications. Robotic assistants helping with household chores without thousands of training hours in your specific home. Wearable AI helping visually impaired people navigate by predicting pedestrian movements. Manufacturing robots adapting to new products without extensive reprogramming. Autonomous vehicles better understanding how other road users behave. What's exciting is Meta open-sourced everything. model weights, training code, benchmarks, all on GitHub and Hugging Face. This isn't locked behind an API. This is genuine open science accelerating progress for everyone. But let's address limitations. The model struggles with long horizon planning, tasks requiring reasoning across multiple timescales. Meta's working on hierarchical V-JEPA models for this. It's also purely visual now. Future versions need audio, haptic feedback, other sensory modalities for truly comprehensive world models. And while physics understanding is impressive, there's still a gap on IntPhys 2. Humans develop intuitive physics as toddlers. V-JEPA 2 isn't there yet, though it's closer than any previous model. The competitive landscape is heating up. Google DeepMind has Genie, simulating entire 3D environments. Fei-Fei Li's World Labs raised $230 million for large world models. But V-JEPA 2 has crucial advantages. It's open source, efficient, and proven on real robots. The efficiency is remarkable. Compared to Cosmos, a competing model taking 4 minutes per action with 80% reaching success, but only 0 to 20% manipulation success, V-JEPA 2 takes just 16 seconds per action, hitting 100% on reaching and 60 to 80% on manipulation. The philosophical implications are profound. For decades, AI research relied on supervised learning, laboriously labeling datasets. V-JEPA 2 demonstrates self-supervised learning from observation. How biological intelligence works is not just viable but potentially superior. This connects to Yann LeCun's broader vision. He's argued for years that the path to human-level AI runs through world models, not just scaling language models. Language is compressed knowledge, but lossy and incomplete. The physical world, observable through video, contains far richer information about how reality operates. V-JEPA 2 puts this philosophy into practice. Meta positions this as foundational research toward AI agents genuinely operating in the physical world. Not chatbots or image generators, but embodied intelligence that can perceive, reason, plan, and act in three-dimensional space with all its complexity. Within a few years, we could see robots powered by world models like V-JEPA 2 performing useful warehouse, hospital, and home tasks. Within a decade, embodied AI assistants might be commonplace, helping elderly people maintain independence, assisting in disaster response, or enabling new remote collaboration forms. V-JEPA 2's release marks a genuine AI milestone. It's not hype or vaporware, it's working technology on real robots achieving impressive results. And because it's open source, thousands of researchers worldwide can now build upon this foundation. If you're a developer, researcher, or just fascinated by AI's future, V-JEPA 2 code and models are on GitHub waiting. If you're wondering whether AI will transform robotics and embodied intelligence, the answer is increasingly clear. It absolutely will. And V-JEPA 2 just showed us how. The robots are learning to see, predict, and plan. The future just got a whole lot more interesting. If you want more AI breakthroughs explained in plain English like this, subscribe, drop a like, and I'll catch you in the next one.